Welcome to week 7, where we will begin tackling hemodynamics and calculations. What I have listed here comes from the ARRT content specifications. And so this is everything that could be on the registry. And what we are going to talk about this week are just the things that I have highlighted. And we will talk about the other items in a future week. So this week we're going to talk about ventricular volume measurement, cardiac output, and the 3 ways to calculate cardiac output: the Fick method, the thermodilution method, and the angiographic method. So we need to review first the normal pressures within the heart. So I have a list here, and at first it's a kind of an overwhelming list. I kind of did that on purpose so that you can practice looking at this information and breaking it down. So CVP/RA, that stands for central venous pressure/RA. See, here's the superior vena cava, here's the inferior vena cava, and there is not a valve between the vena cava and the right atrium. So therefore the pressure will be the same in the central venous pressure and right atrium, which is 5. Then you got the RV, which is 25/0/5, which means 25 systolic. The diastolic goes to 0, and then 5 being the end diastolic pressure. So that's for the right ventricle. You have the PA, which is 25/10. So again, systolic over diastolic. Now I do want to make a note real quick. I have changed this since the last time we talked about hemodynamics. And it's not that the numbers I gave you were incorrect. These are just more correct. I think in the previous lecture I said that the average systolic pressure for the right ventricle was 20, and here I've changed it to 25. And again, both are, correct as averages, but I changed it because, remember, this is systolic, diastolic, EDP, these 3 numbers. And for the PA, you're looking at systolic over diastolic. So the systolic, meaning when this right ventricle is squeezing or contracting, this valve is open. So when this valve is open, the pressure, the systolic pressure, should be the same on both sides of the valve. And if it's not, then that's called a gradient, which we haven't talked about a gradient yet. But anyway, I just wanted to point that out, that I did change this slightly so that the systolic of the right ventricle matches the systolic of the pulmonary artery. The next term is PCWLA, which stands for pulmonary capillary wedge left atrium. So again, we haven't really talked about this yet either, but what they do is they put the catheter deep into the pulmonary artery, and then they inflate a balloon, and what that does is it puts a wedge in it. So from that, they can measure the left atrium's pressure, which again, I know that kind of sounds crazy, but if you think about it, again, there's not a valve located between the pulmonary artery circulation and the left atrium. So they can determine what the left atrium pressure is by placing this catheter into the pulmonary artery. And again, I'll explain that in greater detail later, but for now, the main thing is to have these pressures memorized. So left atrium is a mean or average of 10. Then you've got the left ventricle. So 120 would be your systolic, 0 diastolic, and 10 being your EDP, your end diastolic pressure. From there, then you've got the aorta, which is an artery, and its average is 120/80. So again, it's very important to, first of all, know the blood flow through the heart. I can't say that enough, and it's also important to memorize these average pressures. Okay, so now we will look at some new terms, first being end diastolic volume. So this is the volume of blood in the left ventricle. Now you're going to need to add that. I didn't have that in the notes. But this is EDV is referring to the left ventricle. And then ESV is end systolic volume, the amount of blood in the left ventricle during a contraction. So the stroke volume is the amount of blood ejected in one contraction. The ejection fraction is the percent of EDV, the percent of that diastolic volume that is ejected during systole. So how much in milliliters, how much blood is being ejected from that left ventricle during each contraction. And the ejection fraction represents the stroke volume as a percentage. And then there's cardiac output, which is the amount of blood ejected in 1 minute. So again, this is a lot of terms that sound the same and they seem to be very similar. So it, again, just takes a lot of practice to really sit down and understand each of these terms. Then you need to know the normal volumes for these numbers. So your normal end diastolic volume, so again, this is at diastole, this is when the heart is at rest. Your normal volume of the left ventricle when it is at rest is 50 to 90 milliliters of blood in that left ventricle. When the heart contracts, when that left ventricle contracts during systole, this end systolic volume, there is 10 to 30 milliliters of blood in that left ventricle. So what this means is not all the blood that's in there goes out during a contraction. So, okay, so again, this is 50 to 90 is in there when the heart is at rest, so when that left ventricle is full, and then end systolic is when that ventricle contracts, there's still 10 to 30 ml of blood in that left ventricle. So therefore your stroke volume is going to be your EDV minus your ESV. So this stroke volume is, so if you take what was in there and take what's still in, what, you take what was in there to begin with and then take what's in there at the end and you subtract that, then that gives you how much blood was ejected, how much was ejected from the left ventricle. And then oftentimes they like to display that as a percentage. So 60 to 80% is your normal. So again, it's never going to be 100% because 100% of the blood does not leave the left ventricle. So your normal EF, your normal ejection fraction is 60 to 80%. And then your cardiac output, so that is how many liters of blood per minute. Your normal is 4 to 8 liters per minute.